think I need to say this here. Show the recording. Okay, so I will go over the material that I went over last time. Okay, but this time I use slightly different notation to emphasize future value and present value. Okay, the I is the periodical interest. The M is the number of periods in years. N for number is the number of periods in 1 year. So M will represent the number of periods in years. Basically, the number of periods per year times the number of years you deposit the money. The structure is basically what happened here is one time in, you deposit the money one time. And then after you're waiting for 3 years, then you take all the money out. Okay, so one time in, one time out. Now suppose we have this question, you deposit $10,000, okay, into an account that pays 3% annually. So the interest rate is 3% annually, compounded monthly. So the N, the number of compound periods in a year is 12. And you will deposit that for 5 years. Now, find the balance of the account at the end of 5 years. So if you deposit $1,000, $10,000 right now, how much will that be 5 years later? Okay, now 5 years later, we call that future value. Okay. Now we need to do the setup first. First, I need to find the periodical interest. That's 3% divided by 12. Change it to decimal first. And then you will get 0.0025. That's the periodical interest. And then the number of total period will be 12 times 5, then that's 60 periods. Okay, now then the future value equals to present value times 1 plus I to the M. The future value equals to 10,000 times 1 plus 0.0025 to the power of 60. Then you use your calculator. 1.0025 to the power of 60 multiplied by 10,000. I get 11,616.17 cents. Okay, so if you put $10,000 right now in this scheme, an account that pays 3% compounded monthly for 5 years, then 5 years later you get 11,616.17 cents, $16.17 in that account. Now that's the first example. Second example, we did this last time, so that's why I go a bit faster. Second example, suppose I go the other way around. Suppose Thomas would like to have $30,000 in his account uh, 15 years later. For his children college education. Actually, somebody asked me this question, Thomas, when your children grow up later on, will you send them to college first or go to university right away? And my answer is college if they cannot get any scholarship at university. It's kind of quite difficult to get financial aid in college in form of scholarship. Now, I'm not saying that most students don't. I mean, actually, it's easier in general, but because I expect that when they go to college later on, they're still my dependent, and with my income, very likely they will not get financial aid. Okay, so if I have a choice, looking at the cost, college education, the tuition, college tuition, is a lot cheaper compared to university tuition. Okay, so looking at the numbers, unless my children can get scholarship to let's say tuition free in a university, I will send them to West LA College or East LA College. You know, okay, yeah, but yeah, very likely East LA College because it's closer to my home. But once they go to university, once they transfer, I want them to transfer out. Don't stay at my home anymore. Okay, but of course, for them to have that new start, I would like them, if I really send them out, of course, I would give them some money, but that will be the last support, financial support from me. So suppose I have that plan, okay? I have that plan. 30 years later, 15 years later, I will give my son, let's say, to go out for his education. Now, then how much does he need to deposit now? Let's use the same assumption that interest rate is 3% and it's compounded monthly. That's actually very common, monthly compounding in a bank. Okay, now then solution. That $30,000 is not the current value. That's the future value. So 15 years from now, I want to get $30,000. Fully aware that 15 years from now, $30,000 may not be enough for college education. But hey, you know what? I tell him in advance, you know what? Once you go to college, I give you 30,000 only. You figure out how to get the rest. Okay, I do expect him to actually go to work. I once said this to my stat students at East LA College. I told you I live nearby East LA College, right? And I usually teach there during the weekend, like on Friday or on Saturday. And I once said this to my students that once he reached 4 or 5 years old, I would like him to come together with me to school. When I teach, I want him to actually collect empty cans. That's me. That's me. I want him to learn to earn his money. You know, of course, whatever money he gets, I may just match it also, right? But that will be incentive for him to do that. But I want him to earn his money since very, very young. Okay, that's me though. That's me. And I was actually trained the same way, similar way when I was really young too. Okay, now that's the future value, 30,000. The R is 3%, the N is 12. We have computed earlier that the I equals to 0.0025, and the time will be 15 years. So the number of periods M will be 12 times 15, that's 180. Okay, now future value equals to present value times 1 plus I to the M. Now this time I want my future value to be 30,000. How much money I need to deposit right now? So I get this situation. So that's 30,000 equals to present value. Let me compute this first and make it in like at least 5 decimal places. 1.0025 to the power of 180. That's 1.56743. So my present value, how much I need to deposit right now and leave it there for 15 years. It will be this much. Actually, let me put more. So my present value, the amount of money I need to put in right now, so that 15 years later it becomes 30,000. I need to put in $19,139.59. That's how much I need to put in right now, and just leave it there for 15 years. Okay. Now, I think what I present you here is not really interesting because first, actually, because of the interest rate is too small, 3%. The reality is the interest rate right now is even lower than 3%. It's around 1% something. Okay, such that you don't really feel the difference between $10,000 that you deposit right now and the future value 5 years later. Likewise, in example 2, like if you need to put in $19,000 right now, that's quite heavy though. Put one time $19,000 right now. If you ask me to spend that money right now, I need to think many, many times. Like I don't have that much money, especially I currently still paying for my house, right? Okay, for 15 years later, you know what, 19,000, I'd rather pay the house right now, right? Okay, now then we come up with another scenario. Instead of putting it one time, let's put it in a series of payment. Then we get into something called annuity. Into something called annuity. I will underline this. Now, what is annuity? Annuity is a series of payment. So instead of paying it one time into that account, I paid maybe many times, okay? And in this case, I will talk about ordinary annuity. Now, in practice, when we say annuity, unless otherwise specified, it always refers to ordinary annuity. Now, what is ordinary annuity? Ordinary annuity is a series of equal payments at the end of equally spaced period. What I'm talking about is like this. For example, of ordinary annuity is that I actually put the annuity A, like $500, let's say, at the end of every month. So every month, at the end of every month, I put in $500. Now, what makes it ordinary is first, the amount being put into the account is equal, and it is always at the end of equal space period. So at the end of every month, you can say at the end of every quarter, at the end of every semester, at the end of every year. Okay, so equal amount at the end of equal space. Okay, now we will use the following notation. F Phi A stands for future value of annuity. And A is the annuity itself, how much you pay at the end of every period. Okay. Now the rest follows the same notation. Future value of annuity equals to the annuity times 1 plus I to the m minus 1 over I. Again, where I is the periodical interest and the m is the total number of period over time, t years. Now, that is the formula. That is the formula. And this is actually quite useful for you if you want to see the power of saving, right? Instead of saving one time of $19,000 right now, which is very heavy for me. It's very heavy for me right now, to the point that even if you give me 1 year, I don't think I can actually have that $19,000 in my hand, because I have other things I need to pay, you know, especially if I have that much money right now, I'd rather pay my house, right? Okay, but I don't mind to set aside $500 per month for my children's education, right? For example. So let's see what happens if instead of sinking in $19,000 and forget it for 15 years, how about depositing $500 into that account for, let's say, 15 years, for example. Okay, deposit $500 every month into an account that pays 3% annual rate, compounded monthly, for 15 years. Find the future value. Find the amount accumulated at the end of that 15 years. I think I should say, yeah, of those 15 years. The annuity is 500. So I put $500. Of course, if you were a student, $500 seems to be quite heavy, right? Okay, I think to set aside $300 if you have part-time job may be doable. Okay, may be doable, but I kind of doubt it during this time. Okay, no, don't worry if you can't. Don't worry. Okay, but imagine me. I already have a family, right? I have children, 3 years old, going to 4, and 1 year old. Okay, and I need to pay attention not to focus too much in paying my house, such that when they were ready for college, I'm not ready to financially support them. Okay, so then you know what? Let's set aside $500 per month. Okay, now then The interest rate is 3%. I use the same number interest rate. Of course, later on you look at the actual interest rate in the bank. Okay, so the I, as we have done earlier, that is 0.0025, and P is 15, so the M is 12 times 15, that's 180. Okay, so then future value of annuity. So at the end of those 15 years, how much money I accumulate for my son? That will be 500 times 1 plus 0.0025 to the power of 180 minus 1 over 0.0025. That's equals to 500 times, let me compute the top first, 1.0025 to the power of 180 minus 1 is 0.5674317 divided by 0.0025. Actually, you should not do any rounding on the numerator because you divide by a very small number also at the bottom. Anyway, I get from my calculator when I divide that 226.97269 multiplied by 500. The amount of money I have is $113,486.34. Now, let me change the question to you. And imagine this from a father point of view, okay? From a father's point of view. Which is heavier for a father to come up with $19,000 right now and leave it there for 15 years compared to setting aside $500 at the end of every month? Which is easier? One time $9,000 something, or 180 times $500 every month? Now, you decide. Okay, you decide. Now, you may say, yeah, $500 per month is heavier. You may say, yeah, $500 per month is easier. I agree with you, $500 a month is easier. But you see the effect? What is easier to do turns out giving you more money at the end. You see how powerful it is? You can say this way. Instead, you just need 30,000, right? Remember, I said you just need 30,000. So even if you change this $500, if you change that into 250, if you change it to $250 only per month, but you need to do it every month for 15 years though, okay, you still get half of this, which is $56,000 something, which is still more than the 30,000. So don't underestimate the power of saving. Okay, with this small interest rate, 3%, yes, it is small, right? It is small, but this kind of scheme where you deposit $250 per month for 15 years still get you more, $56,000 something, which is more than $30,000 you get 15 years later by depositing $19,000 right now. So again, $19,000 right now is like a car, right? Call that Honda Civic. I don't think I can make it, dude. I don't think I can make it. Like, I mean, be realistic, right? I don't think I can make it. Even if I can make it, once I offer you the second alternative here, annuity method, you will realize, hey, you know what? Instead of doing it that way, why don't I just put some money in? And you can try even further. Okay, instead of $250 per month, Change it to 200. I think $200 is doable even if you're a student working part-time. Okay. I'm not saying it's easier. I'm saying it's easier. Does it make sense? Okay, it's easier. Yeah, just change that 200 so to 200 instead of $500. Multiply by 200 instead. Then you will still get $40,000 something. Right? Unbelievable, right? Okay. Now, set aside what happens if you save your smoking money, right? The amount of money you, if any of you smoking, my father-in-law smoking, okay, he actually get like around $10 amount of cigarette per week, so it's $40 per month. So change that to $40 per month. Interest rate 3%. Okay, and compounded monthly. And just do that for 10 years. Just do that for 10 years. How much money you get at the end of that 10 years? Can you compute that for me? Let's see if that's enough to buy a car. Go try. How many minutes you want? Should I give you 5 minutes? Yes, 5 minutes, please. So 11:45. Zoom recording for this and about to close this out. Your test 4 will be this Thursday from 11 to 1, and your final will be next Thursday, December 17th. We will do it from 11 to 2. Supposed to be only 2 hours, but I give you extra 1 hour. If you need to send me any email sometime in between or later, make sure you send it. I prefer you to send it by Canvas email, but also, if possible, send it to these 2 emails. Besides Canvas email, also send it to my school email and my personal email. Okay. Now, this coming Tuesday, so next week, exactly 1 week from now, we don't have class. Final week, no class. Okay. But again, feel free to send me an email if you have any question. And if I think you really need emergency help, I need to explain something right away to you, then I may ask you to see me on Canvas. I will try to do something. Okay. But you need to do your part so that I can do my part also. I hope you enjoy the class for this semester and benefit from especially my today's lecture. See you then on Thursday.